So we were discussing about this part. I purposely didn't clean it up because a few references are still remaining. We have discussed wave number. I think you have understood that in 1 millimeter, 600 nanometers, 1666 waves are present. So this is something great for us because in a small distance, you are having 1600 plus waves present. That itself indicates that how short a wavelength is present. And as wavelength is very, very small, we consider here that light travels in a straight line. Are you getting the reason for why we are considering the light as a traveling in a straight line? This is because the wavelength is very small. Just I have asked you to look into the 1 millimeter distance on a scale, and that 1 millimeter distance will be containing 1666 complete waves plus 0.66 of the remaining wave. That would be giving us the wave distance of 1 millimeter. This is extremely small, and that is why we are able to talk in terms of wave number. Okay? After that, you are having velocity. So what do you mean by velocity? Distance upon? Surely. So what do you mean by velocity here? Why you are not calling here speed of wave? Why you are calling here velocity of wave? Are you really considering the direction? You are measuring the shortest distance path. You should have called it as speed of a wave when you are defining it as distance upon time. You will be calling velocity of a wave if it is taken as displacement upon time. Or both will be the same. Am I rightly putting before you the thing? Speed will be defined as distance upon time. Velocity will be defined as displacement upon time. So am I talking of velocity or am I talking of speed? Why velocity? That is my question. Yes? So we consider here that the waves are traveling along a straight line. We say that light travels in a straight line. So can we say here that the wave is traveling in a straight line? And in case of a straight line motion, the distance and displacement are equal. Am I right or wrong? Am I right? As a result, you can call it as velocity of the wave as well as speed of the wave. So can you tell me the formula for it? What will be the formula? Yes? Frequency into wavelength. How do you arrive at frequency into wavelength is velocity? How do you arrive at this? How do you arrive at velocity's formula V is equal to frequency into wavelength? So you are replacing frequency by periodic time. Frequency as 1 upon time period. Why you are taking that? So basic definition goes in this manner that velocity V will be equal to displacement upon time. So if I consider the displacement as equal to wavelength, then time taken by one wave to pass through a given point in a medium is called a periodic time. Am I right or not? What is the period of the wave? What is the period of the wave? The time taken by one wave to pass through a given point of the medium is called as a periodic time. We have talked in the last lecture that number of waves passing per unit time is called frequency. Time upon number of waves is giving us periodic time. So time taken by one wave to pass through a given point, you are calling it as periodic time. One wave, when it is passing through a given point, how much is the distance covered by it? Length of the wave. Length of the wave is a wavelength. So wavelength upon periodic time will give us the velocity. Think about it. I'm not forcing you to accept it, but just think about it. Do you agree or not? I'll again repeat it. Velocity is displacement upon time. If I consider displacement equal to one wavelength, that is length of one wave, that is from origin back to the origin, that will be length of one wave. So for that length of wave, how much time would be taken to pass through a given point? Periodic time. So in one periodic time, the distance covered by the wave will be taken as equal to one wavelength. So wavelength upon periodic time will give me the velocity. Do you agree or not? You have some question, put it down. So you are not getting it? Okay. Anyone else? Have all got this part? So lambda upon t is one form of velocity of the wave. Can I write down this relation as equal to lambda multiplied by frequency, since frequency is 1 upon time period? Can I write down this to be equal to lambda into omega upon 2 pi? Can I write down like this? What I have done, I have taken this step, lambda frequency multiplied by 2 pi divided by 2 pi. So frequency into 2 pi is giving me angular velocity. So I will be able to write down lambda omega upon 2 pi. Can I write down? Yes or no? Can I write down this to be equal to omega upon k? Can I write down this to be equal to omega upon k? What is k here? Propagation constant. So now you are having 1, 2, 3, 4 formulae for the speed of the wave. Speed of the wave is obtained by 4 different formulas here. Frequency is number of waves upon time, 5th formula. Then time period is number of waves, time divided by number of waves. That is the 6th formula. So I think related to this, we are having 6th formula, wave number 1 by lambda, 7th formula, propagation constant, 8th formula, k is equal to 2 pi upon lambda. Are you getting it? Why I am counting this 8 number? Because we have to write down on a page all these formulae one below the other. Right? Every symbol has a meaning, and that meaning is to be written in that particular format. Like omega is standing for angular velocity, k is standing for propagation constant, lambda is standing for wavelength, f is standing for frequency. All these symbols and their meanings are to be written there. Now one thing is still remaining on the board, that is phase. What do you mean by phase? Phase. Yeah. Which? Phase. Now, if you look at the chapter of oscillation and waves, there are two terms that are in use. One is called phase difference and second one is known as path difference. So what is the relation between phase difference and path difference? Like a wavelength, you can make a statement. Like a wavelength means, what is wavelength? Length of a wave. Recollect that out of three definitions, the last one was the most easiest one. Am I right? Similarly, when somebody asks you, what is a phase difference? You should say that it is a difference in the phase. And what is a path difference? It is the difference in the path. Am I right or wrong? So these are the simple definition of what is phase difference, what is phase, what is path difference. Okay? Now we need to understand the relation between the path difference and phase difference. So do you know what is the relation between path difference and phase difference? So normally I put it in this manner, okay? Just try to imagine a situation. We are having a stadium here, right? And you can run around along a stadium. You have called upon the world's fastest sprinter. You understand? Those who are running in a circular track, the world's fastest runner, you are calling upon him. Usain Bolt. Am I right? Am I right or wrong? So Mr. Bolt is here and you have decided to race with him in the stadium. You have told me, you have invited me to see the race. As usual, I am late. Race had already begun. How should I know who is leading and who is lagging? Yep. By saying? You cannot say because both of you are running in a circular on a circular track. If the path would have been a straight line path, then it would have been very easy if the starting point and finishing point are known to me. But these points are not known even on a circular track. How many rounds you are going to move, that is also not known to me. Just I am entering the stadium and I am seeing that both of you are running, the world's fastest runner and yourself. And I am the only person interested in you. Therefore I am there. No other one will come to the ground to watch that. Now, how should I know who is leading and who is lagging? Yes? I told you that I am only interested. I am the third person there. No other person is there. Only three persons are there. How should I know who is leading, who is lagging? I don't know the starting point and the finishing point.
Knowing the position of two of them, even the other person this side, you cover more distance if they start at the same point. So,
But same point, I don't know the starting point, so how can I know the same point? Probably my student had taken more number of rounds and Mr. Bolt is thinking that let him finish 5 rounds and then he will start, still he will win. So probably my student is winning the game. Then how can you decide the same point? There are two ways to identify who is leading or lagging. Not completely, but to a certain extent you can measure it out. The one way is that I should take a tape and run on the same track after you and Mr. Bolt and find out what is the path difference between the two. Looking at my age, that is not possible for me. Right? But if someone is there who is able to run on a track and measure the distance between them, then what he is doing, he is measuring a path difference. Are you getting it? Now, obviously, you may say that, sir, how do you come to know that this is the path difference? It may be the multiple of that. Yes, it is true. But it is giving me tentative idea whether the path difference is 250 meter or I am assuming the circle to be of 1 kilometer and one is leading the other by one round more, then it will be 1.25 kilometer. If he has run 2 rounds more, then he will be having 2.25 kilometer ahead of him. So what I am judging here is the path difference. Are you getting my point here? But looking at my age, it is not possible to go and run after both of you. So better, being a mathematician, I will walk to the center of the circle and I will have an angle subtended between the two. There are 3. I am standing at the center. One is the person ahead, another one is lagging or he is leading. Right? So whatever angle I will be able to subtend at my footstep, I can measure it and I can make a statement that this x is leading the y by a certain angle theta or is lagging by an angle 2 pi minus of theta. Leading by theta or lagging by 2 pi minus theta because he is ahead of it. Right? So this angle measurement is representing the phase. Phase gives you the state of oscillation of the particle. When we are talking here phase pi by 2, you will come to know that the particle is having maximum displacement, giving rise to the formation of crest. When I am looking at the phase 3 pi by 2, then it is telling me that particle is displacing in the opposite direction as that of the crest. 3 pi by 2, you will be having the formation of trough. So phase gives you the understanding about the state of oscillation of the particle. Have you got it? Have you got this clearly? It represents the state of oscillation of the particle, which is important feature for the wave propagation. How the waves are getting generated, can you tell me? It's vibration, but why vibration generates the wave? How the waves are getting generated? Suppose I am tying a rope onto this wall, I am holding the rope here, then how to generate the wave on the rope? How to give the disturbance to it? Now it will depend on how much amount of wave you want to generate. If I am moving my hand from mean position to extreme position back to the mean position, only a crest will be appearing on the rope. If I am moving from mean position to the extreme position, back to the mean position, to the negative extreme position and back to the mean position, one wave will be completely appearing on the rope. So it depends on what type of vibrations had been given to it. If I am making 5 vibrations there in 1 second at a time on a rope, if the length is wrong, if the length of the rope is long and the wavelength is small, you will be able to see the 5 wave at a time. Able to get me? Similarly, we are having a vocal cord. When I make the vocal cord vibrate, I am able to see that the wave is traveling in all possible direction. In case of a rope, the material of the rope is present only in one direction, therefore one dimensional wave is getting generated. But if it is a solid and you are generating the transverse wave through it, then that transverse wave will be traveling in all possible direction and we will be having the wave generated on account of vibration there. Are you getting me clearly? There are two types of waves. We call it as transverse wave and longitudinal wave. Can you explain me what do you mean by transverse wave? Can you explain me what is a transverse wave? Can you explain? Up and down? How many types of waves are there? I know your answers are transverse and longitudinal, but that is not the question I am asking. Yes? Mechanical and? Correct. There are two types of waves, mechanical wave and non-mechanical wave. What do you mean by mechanical wave? Which requires the material medium for propagation, you call it as a mechanical wave. Which do not require the material medium for the propagation, you call it as a non-mechanical wave. Now you are having two types of waves, mechanical and non-mechanical. In a mechanical wave, there are two types of waves. One is transverse wave, another one is longitudinal wave. So what do you mean by transverse wave? And probably in that chapter of oscillation and waves, you have learnt about linear, simple, harmonic, progressive wave. What do you mean by this combination of word? Simple, harmonic, progressive wave. Anyone who can explain to me what do you mean by linear, simple, harmonic, progressive wave? Or simple, harmonic, progressive wave? It's very simple. Any wave is going to be progressive in nature. Progressive means which travels only in forward direction, you call it as a progressive wave. It is progressing ahead and ahead, you are calling it as a progressive wave. Simple harmonic word is used here because you require a material medium for the propagation of the wave. So the particles of the material medium are performing simple harmonic motion and wave is progressing ahead and ahead. You are calling it as simple harmonic progressive wave. I think you have completed the oscillation. Oscillation part. Have you completed? Yes or no? Oscillation. So what is the condition for linear simple harmonic motion? K is equal to 1. Why K? What is K? Which constant? Here we have defined K as propagation constant. Now these all words are extremely important because these are somewhere related to the light wave also. Linear simple harmonic motion is defined as an oscillatory periodic motion along a straight line path in which acceleration or restoring force is directly proportional to the displacement and is oppositely directed, then only you will be calling it as linear simple harmonic motion. First thing you require is an oscillatory motion. Second thing, it should be a periodic motion. Third thing, that the path should be a linear path, a straight line path, and in addition to these three conditions, you require acceleration of the particle directly proportional to the displacement but oppositely directed, or restoring force directly proportional to the displacement oppositely directed. These 5 conditions are to be satisfied to be called as a case of linear simple harmonic motion. If any one of the condition is not satisfied, you will not be allowed to call it as linear simple harmonic motion. Restoring force directly proportional to displacement and oppositely directed. Are you aware of this term, restoring force directly proportional to displacement, oppositely directed? Sure, or should I explain that also? One thing is known as Hooke's law of elasticity. Have you studied the Hooke's law of elasticity? What is that? Within elastic limit, stress is directly proportional to strain. This is the one form of Hooke's law of elasticity. Second form? Whenever you are learning about elasticity, are you considering the area of cross section to be constant or variable? Like you are talking about Young's modulus of elasticity, are you taking area of cross section constant or variable? In Young's modulus, while studying the Poisson's ratio, you are considering the area of cross section to be changing. But while studying the Young's modulus, area of cross section is taken as a constant. The original length of the wire is also taken as a constant because there is no deformation in the original length. So stress is directly proportional to strain, means force upon area is directly proportional to the extension upon original length. Original length is constant, area of cross section is constant, so force is directly proportional to extension. मैंने क्या बोला समझ में आ रहा है क्या कि मैं फास्ट बोल रहा हूं? आपने मुझे यह बताया हुक्स लॉ में कि स्ट्रेस within elastic limit is directly proportional to the strain. Am I right? ये आपने बोला. What is stress? Force per unit area. So you are writing here force per unit area directly proportional to strain, extension produced upon original length. In Young's modulus of elasticity, area of cross section and original length are constant. So it will be force directly proportional to the extension. Am I right or wrong? बराबर है? This is Hooke's law of elasticity. तो आपने स्ट्रेस और स्ट्रेन में देखा, मैंने उसको फोर्स और एक्सटेंशन में बताया. एंड दिस लॉ इज अंडरस्टूड बाय एवरी किड इन इंडिया. Either you have experienced as a kid or you have given experience to the kid. You are having a broken rubber band. You hold one end of it and ask your younger brother or sister to stretch it. He goes on stretching it, and then you say, more, stretch more, stretch more. He further stretches it apart, and then you leave it. Then he is doing like this. Force is directly proportional to extension. More is the extension, more will be the force. Lesser is the force, lesser will be the extension. Lesser is the extension, lesser is the force. Have you done it on someone? Have you experienced from someone? Are you getting this part? तो यही तो रिलेशन है, यही तो मैं सिंपल हार्मोनिक मोशन में भी बता रहा हूं आपको. रिस्टोरिंग फोर्स इज डायरेक्टली प्रोपोर्शनल टू डिस्प्लेसमेंट, अपोजिटली डायरेक्टेड. Restoring force is directed towards the mean position, and position of the particle is measured from mean position. So obviously the directions are opposite, therefore F is taken as equal to minus of kx. Oscillation, linear simple harmonic progressive wave, we are having 5 conditions. The particle should perform linear simple harmonic motion. Linear simple harmonic motion means the path should be a straight line path. The particle should have oscillation. The oscillatory periodic motion it should have, and in the oscillation, restoring force is directly proportional to the displacement, oppositely directed, or acceleration is directly proportional to the displacement, oppositely directed. That is what we call it as the condition for linear simple harmonic progressive wave. The word progressive wave is called because somebody has put on the switch, the light will come down. Somebody puts off the switch. Are you able to see that the light is moving back? Have you ever seen that? Switched on, light is falling down. Switch off, light is moving back. Have you seen it? This can be shown only in movie. Why? Because they can cut the film and rearrange in a reverse order and play it. So they show sometimes in movies that the light is moving back, but actually it never. Light do not travel in backward direction. Sound do not travel in backward direction. Sound is progressing only in a forward direction. Light is progressing only in the forward direction. Any energy will be traveling only in the forward direction, and that is why the wave has been called progressive wave. समझ में आ रहा है? Are you all getting it clearly? So this is a simple harmonic progressive wave in which we are having these physical quantities that are described here. Now there is always a big tussle. You are able to see that when a particle is performing simple harmonic motion, does it have frequency? We call it as frequency of oscillation, right? The particle is performing simple harmonic motion. Does it have time period? Yes or no? We call it as periodic motion or periodicity of oscillation, right? When a particle is performing oscillation, does it have amplitude? Yes, it does have amplitude. So whatever we have talked of the wave, the same are the aspects of particle oscillation. True or not? So velocity of wave, amplitude of oscillation is amplitude of wave, that is true. Particle jahan tak displacement karega, the distance, perpendicular distance up to which the particle is going to have displacement, maximum displacement you call it as amplitude. Same is the amplitude of the wave. Am I right or not? The particle is having maximum displacement up to a particular position. That maximum displacement is called amplitude of oscillation. Same is the amplitude of wave. Am I right or not? Okay. Period of wave and period of oscillation will be equal. Frequency of oscillation and frequency of wave will be equal. Am I right or not? Right? What about velocity? Can I say velocity of the wave and velocity of the particles are equal? Velocity of particle performing simple harmonic motion is equal to velocity of the wave. Why not? Oscillation is in a circular path. We have defined only linear simple harmonic motion where the oscillation is taking place along a straight line path. In an oscillation, when the particle is at the mean position, the velocity is maximum. When the particle is at the extreme position, the velocity is zero. We say that the particle is momentarily coming to the rest. From position to position, the particle velocity of oscillation goes on changing. But velocity of the wave in a medium is a constant, and that is the relation that velocity of the wave in a medium is not equal to velocity of the particle performing simple harmonic motion. You can say, sir, I was saying the same thing. Yes, you said the same thing, but the logic and reason, I felt it that you are not talking of. That is why I explained it. Okay? So it's very important that velocity of the wave is given by frequency into wavelength. What will be the velocity of the particle? Formula for velocity of the particle. in oscillation you have written these two formulae. So these are the expression for velocity of particle performing simple harmonic motion which causes the formation of the wave. There are two types of waves, we have described it. When the oscillation of the particle is perpendicular to the direction of propagation of wave, then we call it as a transverse wave. Transverse is a perpendicular. So if particle is oscillating along a straight line path perpendicular to the direction of propagation of the wave, then the wave is called transverse wave. And if the particle is oscillating parallel to the direction of propagation of wave, then it is called a longitudinal wave. Have you got me? Particles are oscillating perpendicular to the direction of propagation of wave. You are calling it as transverse wave. Particles are oscillating parallel to the direction of propagation of wave. You are calling it as a longitudinal wave. Transverse means perpendicular. Longitudinal means along the direction of propagation of wave. Particles oscillate along the direction of propagation of the wave. You call it as longitudinal wave. Have you got the background now? So we have talk of mechanical waves, non-mechanical waves. Light is it a mechanical wave or non-mechanical wave? Non-mechanical wave, right? Now, suppose I am heating the surface here like this. What type of waves are generated on the tabletop? Longitudinal or transverse? On the tabletop you can do it and find it out. I know, what do you like? Longitudinal or transverse? So I know how to program your brains, and I'm an effective programmer. Now you can check it out what type of waves are getting generated very easily. Suppose I ask him to place a palm on the tabletop and I start heating it here. Are you able to feel the vibration there? So my vibrations are in this manner, up and down, and he is feeling the wave at a long distance apart, which is perpendicular position, so that is a transverse wave. Now do one thing, touch that palm from below the table, and I am still hitting it in this manner. Are you able to feel the vibration? So waves are traveling downward also. So when you touch the bottom of this particular plank, you are able to see a longitudinal wave, and when you are touching the top of this particular plank, then you are having a transverse wave. Now what I did, I have given you the option only whether it is longitudinal or transverse, and you started thinking about only one. Both are the answers here. Have you got me? So when you keep it from the bottom and I'm heating from the top, the vibration from the top are moving to the bottom in the same direction as the wave is traveling, so it is longitudinal. And when you are keeping on the tabletop and beating it here, then the vibrations are felt at this point. It is because of the transverse wave. Are you getting my point here clearly? So, कैसे सोचना है, how you should think, that I have explained to you whether how it is longitudinal, how it is transverse. Okay? Now, Now, actually, we want to have some review more of the light. We have done some part of the review that is there, but still we want to find it out. So first important thing is that light, we are considering it as an electromagnetic wave. So are you all aware of it, electromagnetic wave? Yes or no? Sure. So can you do some calculations for me? Related to the first chapter of measurement. Should I rub it off? So there is a formula which is probably known to you, and that is F is equal to 1 upon 4 pi epsilon 0 Q1 Q2 divided by R square. Is it known to you? Can you find out the dimension of epsilon 0? I'm saying dimension. Tell me unit as well as dimension, I don't have any problem. Unit bata do, koi problem nahi. So unit of epsilon 0, as he is rightly pointing out, how much it is? Epsilon 0 will be Coulomb square upon Newton meter square. आप उल्टा बता रहे थे शायद. Similarly, there is one formula. This is actually Coulomb's law, right? So one more formula is there, and that is पता है या नहीं पता है? दूसरा भी फॉर्मूला बता देता हूं. जैसे आपने ये फॉर्मूला लिखा है, वैसे और एक फॉर्मूला है, दैट इज F इज इक्वल टू म्यू 0 अपॉन 4 पाई. You are having here pole strength square divided by R square, where M is standing for pole strength. शायद इसके पहले ये फॉर्मूला देखा होगा, M इज इक्वल टू स्मॉल m मल्टीप्लाइड बाय ट्वाइस L. 9th 10th में ये फॉर्मूला देखा होगा, आई डोंट नो, मैं लिख देता हूं. दिस M इज स्टैंडिंग फॉर मैग्नेटिक डायपोल मोमेंट. ट्वाइस L इज डायपोल लेंथ. And M is standing for pole strength. Right? Help और कर देता हूं. That pole strength, इसका जो यूनिट होता है, that is एम्पियर मीटर. Can you find out the unit of mu 0? Rest of the things are known to you. 4 pi is a constant, R is a distance. Can you find out the unit? If you have any question, you can ask me. I'll help you out. Mu zero is called permeability. Permeability of the free space. Can you get the unit of mu zero? Come on, please answer it fast. Yes? So you can put it down very easily, Newton meter square upon ampere square meter square आएगा ना? आपका mu zero इधर हो गया. You are having 4 pi f into r square divided by m square. 4 pi का तो कोई यूनिट नहीं है, तो unit of mu zero will be taken as equal to Newton meter square divided by pole strength है. Pole strength यानी ampere square meter square आएगा. So you will be having meter square getting cancelled. This is Newton per ampere square. बराबर है या नहीं? Is it right or not? Okay? Okay? If this is so, what will be the unit of 1 upon mu 0 epsilon 0? Unit of 1 upon mu 0 epsilon 0. Epsilon 0 का भी आपने यूनिट निकाल दिया है, mu 0 का भी यूनिट है वहां पर. Can you tell me what will be the unit of 1 upon mu 0 epsilon 0? So you can substitute it. You will be able to have this to be equal to 1 upon mu 0. So you will be having 1 upon mu 0. यहाँ पर आपने mu 0 का निकाला था, बराबर है? तो reciprocal will be ampere square upon Newton. So this will be, या यहाँ पर लिख सकते हैं Newton upon ampere square multiplied by 1 upon epsilon 0. 1 upon epsilon 0 का आएगा यहां पर कूलम स्क्वायर अपॉन न्यूटन मीटर स्क्वायर आएगा. एम आई राइट? आई एम जस्ट सब्स्टिट्यूटिंग इट. एम आई राइट और नॉट? राइट. नाउ कैन आई कैंसल न्यूटन? कैन आई कैंसल दिस विथ दिस टू प्रोड्यूस? Sorry, this will be second square here, not here. Check it out. Am I right? ठीक है? इसको सॉल्व करेंगे तो you will be getting this as meter square upon second square. Got it? Sure? Now, so unit of 1 upon under root of mu 0 epsilon 0 will be equal to meter per second. Sure? Are you all getting it clearly? You might be thinking, what is happening? Sir is starting with Newton's Coulomb law, asking you to talk about the epsilon zeros unit, then giving some formula, asking you to talk about the permeability, right? And then taking the product, taking a reciprocal, and you are able to get here 1 upon under root of mu 0 epsilon 0. Uska jo unit aega, the unit of that will be turning out to be meter per second. You are probably not aware, but mu 0 is taken as 4 pi into 10 to the power minus 7. Mu 0 का यूनिट आपने लिखा हुआ है वहां पर, न्यूटन पर एम्पियर स्क्वायर, राइट? And epsilon 0 is having the value 8.85 into 10 to the power minus 12. Epsilon 0 का यूनिट कितना आता है? कूलम स्क्वायर अपॉन न्यूटन मीटर स्क्वायर. Okay? So, if I put down 1 upon under root of mu 0 epsilon 0, that will be equal to 1 upon under root of 4 pi into 10 to the power minus 7 into 8.85 into 10 to the power minus 12. Can you solve and get the answer? You can make the use of calculator or any way to get the answer here. The value of pi can be taken as 22 by 7 or 3.14. I'll help you to a certain extent. Am I right? आ रहा है क्या? Are you getting that? No problem. It's like this, that if you knew before, then you should have got the steps earlier also. So you know the final part of it. This calculation will lead to the speed of light. You can check it out by doing the calculation, because this 10 to the power minus 18, when it will be moving up, it will be appearing to you 10 to the power 9. This is in this manner. 4 4s are 16, carrier 1, 4 5, 4 3s are 12, so 1.256. This is 2 digit, but 10 to the power minus 1 भी मैंने ले लिया, इसलिए 1.256 आ गया, multiplied by 8.85 आता है. If you solve it, you will be able to see that the final answer will be around 3 into 10 to the power 8 meter per second. This proves that the value of speed of light is given by 1 upon under root of mu 0 epsilon 0. So speed of light comprises of permeability of the free space and permittivity of the free space. Permittivity of the free space comes from the electric field, permeability of the free space comes from the magnetic field, and that is the reason why light has been thought of as an electromagnetic wave. So how Maxwell arrived at the conclusion that light is an electromagnetic wave, the same way has been demonstrated to you. How did Maxwell thought of electromagnetic wave? This is the background behind it, which will also allow you to understand how Maxwell was thinking about electromagnetic wave. Have you got it? Mu 0 is coming from magnetic field, epsilon 0 is coming from electric field. So combination of electric and magnetic field produces an electromagnetic wave. Okay? Got this part? Any questions here? Second? So this part, now, what is the unit of mu 0? Newton per ampere square. So 1 upon Newton per ampere square will be there. Got it, or should I explain further? And this is giving you Coulomb square upon Newton meter square. So Coulomb square is getting cancelled with ampere square to produce a second square here, because ampere is Coulomb upon second. So second will be coming to this place. That is how it is there. So did you get the idea how electromagnetic wave came into existence? This was the unit analysis which Maxwell had did, which he found that it is related to the electromagnetic field as well as electric field and magnetic field. That is why we consider the light to be an electromagnetic wave. Okay? Electromagnetic wave do not require any material medium for its propagation. They can travel easily through the vacuum. Light is not affected by electric and magnetic field. So if you are taking some electric field and you are making a light pass through it, you will never see that light is getting attracted towards the positive part of the field or negative part of the field. It will remain undeviated. Electromagnetic wave is undeviated by the magnetic field also. So these are the characteristic of electromagnetic field or a light wave. Okay? So have you studied dispersion of light? When you are taking a prism and making a white light pass through it, what happens? It splits into? It splits into 7 colors. Which are those 7 colors? Vibgyor. What is Vibgyor? Orange and? Are you all aware of it? What is indigo? What is indigo? Color. Indigo is a color. I think indigo is a flight. Both. What is indigo? Sir, I am color blind, so I don't know what is indigo. Color blind? Indigo? Which color you would like to call it as indigo? So how many of you have seen the rainbow here? In your life, have you seen a rainbow? Here means you are looking for where is the rainbow. Have you seen the rainbow in your life? How many colors do rainbow have? How many colors do rainbow have? How many of you say 7? Raise the hand. You are asking your neighbor. Raise the hand, raise the hand. How many of you say that you have seen all 7 colors? Raise the hand. Nobody is there to raise the hand. But how many colors does it have? 7. So without counting, 7. I think he has only seen the rainbow. Because he has rightly pointed out 3 to 5 colors, not more than that. Those who are saying 7 colors, they have never seen the rainbow in their life. Next time when you are able to see the 7 colors, take a picture and send it to me. Because I am watching since my childhood how many colors are there and I have never seen above 5. That's true. सात रंग कभी दिखते ही नहीं है. That is why I am asking you, which are the 7 colors? What is indigo? Because when you say that, you can look at the dictionary. You might have a dictionary with you. You will find that Oxford Dictionary says that indigo is a shade of blue. So you will find that there are shades of yellow, there are shades of brown, there are shades of red, there are shades of green. Then all other color shades are not considered in a visible light, and only indigo is considered. You are having the shades of red. So actually, how many colors are there in a visible spectrum? The answer should be infinite. 7 is a wrong answer. And if you observe it, there are 6 colors only. Shade of blue has been added to it. Tell me, whatever spectrum you are able to see through the prism, that spectrum, is it having all the visible light or non-visible light? Whatever you are able to see is called as visible light, na? So you are having all visible light there. So do you say that red color only one wavelength is present and blue color 2 wavelengths are present? Or all wavelengths of red, all wavelengths of blue, all wavelengths of violet, all wavelengths of red, orange, yellow, green, all wavelengths are present. So you can say that basic constituent colors are 6, but actually there are different colors or infinite colors in a spectrum of white light. Are you getting me clearly? Getting it? So what about the wavelength of these colors? Anybody who is aware of wavelength of the colors? This is Webjord. So can you tell me the wavelengths? So when you are talking of violet color, the wavelength ranges from 400 nanometer to 450 nanometers. So this is actually 400 to 450. All answers are expressed in terms of nanometer. Indigo, 450 to 500. Right? Wavelength we are talking here. Then green, 500 to 550. After that, yellow, only 500 difference is there. So will you be able to build that wavelength range? So this is actually the whole of blue. So this will be containing from 450 to 500. Then green will be present here 500 to 550. Then 550 here, 550 to 600. Then you will be having here for the orange 600 to 650. And this is actually 650 to 700. These are the wavelength range expressed in terms of nanometer. Have you studied in chemistry halogenation reaction? What is that? Adding of halogen to the chlorine. No, halogen to the methane, ethane. Right? There is a condition written there. RH plus Cl2 in presence of ultraviolet light gives you RCl plus HCl. Am I right or wrong? I dropped chemistry after 12th standard. Right? Why you are mentioning ultraviolet light? It's a fashion to write down. How can you say that ultraviolet is having the higher energy? How can you say that it is having higher frequency? So lower wavelength means higher frequency. Why so? Both are? Both are inversely proportional. That can be a reason for it. I am asking you, why they are inversely proportional? Why they are inversely proportional? I think you are yourself confused. More is the wavelength, more will be the time taken, more is the time taken, lesser will be the frequency. The part which I have taught you, I am talking about the same. What is speed of the wave? Speed of the wave. Speed of the wave. Formula क्या बताया? What is the formula for speed of the wave? That you learned today. Omega upon K. What is known to you? Velocity of the wave. Frequency into wavelength. And I was asking you how they are inversely proportional. You have to only say that speed of light in an air will be remaining constant. So speed of light is remaining constant. So frequency into wavelength is a constant. So it means that frequency is inversely proportional to the wavelength. So it should have started with the speed of light being constant. Am I right or not? हम कहां से कहां चले गए? नहीं, वेवलेंथ कम है तो फ्रीक्वेंसी ज्यादा रहेगी, यहां से चालू किया. You started with this part that if frequency is less, wavelength is less, frequency will be more. I asked you why. You said it is inversely proportional. How can you prove that it is inversely proportional? Then you started building the rocks on it. You know, if the wavelength is more, it takes more time to travel. It was so simple that speed is remaining constant. If speed is remaining constant, the product of frequency and wavelength is constant. Product of frequency and wavelength is constant. Then it would be inverse relationship. Was it difficult? When I asked you what is the velocity of wave, omega upon K, what it has to do with frequency and wavelength? Start thinking on a right direction. Okay? So have you got the answer? So write down the frequency ranges of each of them. That is a task given to you. Can you find out what will be the frequency range of violet? आ जाएगा ना? Will you be able to get the answer? Now the idea is very important that wavelength is less on this side. So I can put down lambda for the violet is less than lambda for the indigo, less than lambda for the blue, less than lambda for the green, less than lambda for the yellow, then less than lambda for the orange, less than lambda for the red. Okay? So frequency wise, you will be able to write down frequency of violet is greater than frequency of indigo, greater than frequency of blue, greater than frequency of green, greater than frequency of yellow, greater than frequency of orange, greater than frequency of red. So which color will be having the minimum frequency? And which one is having maximum frequency? What is the formula for energy of photon? So energy of photon, you are always putting it as E is equal to h nu. So energy is directly proportional to the frequency. So energy of photon of the violet color is going to be greater than energy of photon for the red color, since frequency of violet color is going to be greater than frequency of the red color. Am I right or not? So to break the bond RH, you require a large amount of energy, and that is why ultraviolet light has been used there. Have you got in chemistry why you are having the halogenation reaction mentioning the ultraviolet light? Are you getting the answer now? So it is bond. RH bond, you have to break it to form RCl. So that RH bond to break down, you require a large amount of energy which is corresponding to the energy of a frequency of a violet photon. That is why you require ultraviolet light, because ultraviolet will be lying on this side. This is the region you will be having UV. UV will be again onto the left side, you will be having X-ray. Here you will be having gamma ray. On this side of the region, this is visible region. यहाँ से यहाँ तक का जो region है, that is visible. इसके बाद आएगा infrared. Infrared के बाद आएगा microwave. Microwave के आगे? Radio waves. Right? So you should be aware of this particular spectrum here. So have you seen this part, microwave? Have you seen a microwave which is used to heat the food items? Have you seen that microwave? It is using this microwave lens. So when you are having a radiation of microwave done on any food item, it is getting hot. Why? Anybody knows the answer for that? Can you tell me any food item which do not have water in it? Any food item which do not have water in it? Chips? Papad? Does it have a water or not? Any food item which do not have water? बोलिए ना. Come on, say. Salt में पानी नहीं होता है. Why they are popping on? Popcorn pops. That is why the word popcorn is coming there. Why they pop up? The seeds have a water content. So when you put it in a microwave, you are able to see, because of the heat generated by the water molecule, they are expanding. So it has a water content. Even if you are having now the popcorn available that you can cook it in a cooker, you will find the vapors getting collected there. So it is having a water content. Even if the papad is dried one, it is containing the water content. There is no item, because if you want to make it a papad, first you have to put it some water and then you dry it out. So some water content is still present there. Are you getting my point? So there is no food item, and this property of water has been used when you are using a microwave. Then this microwave causes a resonance with the water molecule, and water molecule begin to vibrate extensively harder. The amplitude of vibration is so large that it starts producing the heat, and that is why every microwave item, food item, gets heated from inside. That is how the difference is there. So this microwave is the same microwave which we are marking it here. So this particular part must be known to you. Okay, one more interesting question is there. Why matka kulfi wala wraps a red color cloth? Have you seen a matka kulfi wala? It's actually ice cream, you can say kulfi. It is contained in a earthen pot wrapped with red color cloth. Why? Look, he's saying that red color absorbs more heat. So once you are out of the school premises and wearing a red color t-shirt, you want to absorb more heat. More less heat. Wow. So red absorbs less heat. As compared to what? So you want to absorb less heat or more heat? That is why you are putting red. Why matka kulfi wala is wrapping a earthen pot with a red color cloth? Anyone? So red color keeps the kulfi cool. All those kulfi wala loves red. Look, I am telling you, don't forget about my Guru Dakshina. All these questions are for others, not for you. Ask them. Such questions are really interesting. Why panwalas are using a red color cloth? Any pan shop, you will find that he puts all the pan on a red color cloth. The moment I start putting these questions, you start thinking about the question. But similar question you have handled earlier, I am asking the same question to you. You have to connect with that. Why in a traffic signal you are using a red, green and yellow color? Why they should travel more distance if the speed of red color, yellow color, green color in air is same? Red is more intense. Something is going wrong in you. Red is more intense. It all depends upon the power. You are comparing a 0-watt red bulb with 100-watt white bulb. You will find that 0-watt bulb is having more intensity as compared to the 100-watt bulb. What a tube light there. Yes, red will. So do you mean to tell me that colors do bend? Why they should bend? On the other hand, in case of prism, the violet light is bending more, red light is bending less. So are you passing that red cloth, earthen pot through the prism to see whether it is bending more or less? कुल्फी वाले को प्रिज्म से जब मैंने भेजा था, जाएगा क्या वो? पहली बात तो वहां से शुरू होगी. Why yellow and green? Why doctors are using a green color apron while performing the operations? Why you are able to see the wall white in color? White contains all the color. But the tabletop are appearing to you light brown. You are having a red rose and a green stain seen in a white color. It will have red rose appearing to you as red and green stem appearing to you as green. If you take a red rose with a green stem in a red light, how the red rose will appear to you, how the green stem will appear to you. If you are taking a red rose and a green stem in a green light, how it will appear to you. If you are looking the red rose and a green stem in a blue light, how it will appear to you. What is the conclusion of all this question? Sir, don't have any work to be done. He is playing with the red rose and the green stem, taking it from different colors to see the effect. Come on, think about it. It's all about the color. Anyone? What about my Guru Dakshina? You always forget about it. So the idea is very clear. The word you were missing and I was playing upon is scattering. Red light scatters less. Blue light scatters more. And that is why the sky appears to you to be blue, because blue is maximum scattering color. When you are using a red color light in a signal and the vehicles are coming from a very long distance with a very high speed, they will be able to cross the signal in a fraction of a minute or fraction of a second. In that case, they should be able to see the red color from a long distance. Red light suffers minimum scattering, so it is not getting dispersed, it is not getting scattered, as a result of which can be seen from a long distance. Same is the answer why a kulfi wala is wrapping a red color cloth. This kulfi wala goes on calling the name kulfi kulfi while he is moving on the road. Sound gets attenuated or die out after a very small distance. We are talking here, but my voice is not going to travel along, even though I am talking with the help of mic system. It has a certain limitation, but a red color cloth can be seen from a long distance. So a kid who wants to buy a kulfi, if he sees from a long distance the red color cloth, he will pull his mother towards a kulfi wala to get kulfi for him. That is the reason why he is using a red color cloth. Why panwalas are using a red color cloth? They are very smart. Because you will find that red patches on the red cloth cannot be identified soon. Because they are using some red color powdered slurry and putting it on a pan. That patches on a white cloth will be much more brighter, but on a red cloth will not be visible. So the same cloth can be used by him for a month. Nobody will be able to find it out how dirty that panwala's cloth is. So that is why red. Why doctors are having a green color apron? So when they are giving a cut, if the blood comes out of the patient's body and falls on the apron, it will not appear to the patient as red in color, it will appear to the patient as dark in color. Because the effect of anesthesia is that he doesn't feel the pain, but his eyes are open, then he will be able to see. Now, if the doctors are putting a red color apron, red blood color apron, and the patient is seeing it during the anesthesia, he is not aware, his eyes are closed. After opening the eyes, he is able to see the whole doctor's apron with a red color. He will think that he is going to die, his BP will be fluctuating. So these people go for a green color cloth so that red stems on the green color cloth will appear to you as dark. Red rose, green stem, seen in a white light falls on a red rose, it absorbs all the color except the red. So red is getting reflected from the red rose. Green is getting reflected from the stem, and that is why red rose, green stem in a white light will appear to him as a red rose and a green stem. But when you are taking a red rose with a green stem in a red light, then you will find that red rose will not absorb the red color, it will emit the red color, it will reflect the red color, so red rose will appear to you as red rose. Whereas green stem will absorb the red color, so it will appear to you as dark. Whereas when you are looking at a red rose and a green stem in a green color, then green color, when it is incident on a green stem, it will be reflected as a green, because green will not absorb green. But red rose will absorb green, so red rose will appear to you as a dark rose. If you are having a red rose and a green stem seen in a blue light, it will be a dark rose with a dark stem. Because green light will be absorbed by the red rose as well as by the green stem. Getting my point clearly? Any question there? So got the answers of all? Why yellow and green is still remaining? Why yellow and green? The answer is on the board. Okay. In a visible region, the color starts with? What is the minimum value of wavelength of violet? 400 to 450, take it as 400. And it ends with red. What is the maximum wavelength of the red? Find out the average of it. $550. What you are able to see at 550? Green ends, yellow starts. Am I right or not? Green ends, yellow starts. That is 550. Our eyes are more sensitive to the central region of a visible spectrum, which is yellow and green, and that is why we are having traffic signal yellow and green. Are you getting the point? These are designed from the point of view of physics only, and that is why these questions become very important. Why we are having yellow and green to be taken, because they are at the center of that particular spectrum. Able to get this? Are you getting this part clearly? Okay. So these wavelength ranges, frequency ranges are extremely important. We have not worked on a frequency range. I have given you as a task that you will be able to make the list of frequency range, because that will be useful to you when you will be looking at photoelectric effect, where energy of photon will be playing some important role. That part will be important there. Say,